Hello, I'm John Mark Dacumos, and the topic that we will discuss is about wind farm. And let's talk about the wind turbine operating principle first. So, wind turbine is a type of renewable energy that harnesses the power of wind to produce electricity. The basic idea is that wind turbine uses rotor with attached blades to collect wind's potential and kinetic energy. Wind turns the blades, which spins a shaft that is connected to a generator, which results in generation of electricity. A large number of wind turbine is usually called wind farm. And here how wind turbine looks when operating. And this is the closer look of a wind turbine. As we can see, the rotor consists of blades, and the part where the blades are attached, we call it hub. At the back part of it, this some sort of housing, we call it nacelle. For better understanding, I have here the cut-out view of the nacelle, which consists of low-speed shaft, gearbox connected to the high-speed shaft, and lastly the generator. As we could observe, these individual parts are all interconnected to the blades, which once again, this part is the rotor, which consists of the blades. Where the blades are being attached, we call it hub. Let's have here more close-up view of wind turbine while it is operating. As we can see, since the vital part inside the nacelle are all interconnected to the blade, once the blades rotate, it will cause the rotation of the following: the low-speed shaft, the gearbox, the high-speed shaft, and the generator. And at the back of the nacelle, where the shape is triangle, we call it wind vane. And this is used to detect the wind direction. And these three balls-like rotating mechanism, this is the anemometer, which is used to measure the wind strength. Next is the parts and operating principle of a wind turbine. As we could see, we are not able to mention the portion right below the nacelle a while ago, so-called yaw mechanism, that consists of yaw drive, yaw motor, and some other small parts. Let's now discuss the function of its individual parts. The vital part inside the nacelle are all interconnected with the blades, and the blades are being attached to the hub. And then once the blades rotate, it will cause the rotation of the low-speed shaft, gearbox, high-speed shaft, and generator. And as we could notice, we have here the brake, and the next presenter will discuss it.
Next, we have the parts and design of wind turbine. First, the blade design. To produce an amount of power, wind turbine blades generally need to be large and tall. It is shaped to generate the maximum power from the wind at the minimum cost. Improvements in the design has produced new wind turbine which are more compact, quieter, and generates more power from less wind. The largest wind turbine in the world was Goldwind GWH 252-16 MW turbine. The Goldwind GWH 252-16 MW turbine, which was installed at an offshore wind farm in Fujian province in June, produced 384.1 MWh in a single day, enough to power roughly 170,000 homes. So next we have the airfoils. Airfoils is the cross-sectional shape of the blades that determines its aerodynamics. They are key to blade designs. This airfoil design allows the blade tips of a wind turbine to move faster than the wind is moving, thus generating more power and higher efficiencies. Two types of airfoil design: the thin airfoil family for medium blades and the thick airfoil family for large blades. So for the thin airfoil family for medium blades, first, the tip region airfoil that has 95% radius, primary outboard airfoil, that has 75% radius and the root region airfoil that has 40% radius. And for the tip airfoil family for large blades, first tip region airfoil that has 95% radius, primary outboard airfoil that has 70% radius, and root region airfoil that has 40% radius.
Blade aerodynamics. So, yung wind turbine blade, nagwo-work siya by generating the two aerodynamic forces, which is yung lift force and yung drag force. So, yung lift force, ito yung force that makes the blade rotate. While yung drag force naman is in opposition of the motion, which is yung drag force yung pumipiga sa pag-rotate ng blade. So, lift and drag formula. So, ito yung formula sa lift. So, yung L stands for lift. Yung C sub L is equals to coefficient of lift. Yung parang letter P is equals to the wind density, V is equals to velocity, and A sub B is equals to area of the blade. So, ito naman yung formula sa drag force. D stands for drag force, C sub D is stand for coefficient of drag, yung parang letter P is wind density, V is equals to velocity, and A sub R is the reference area. So, yung reference area, ito yung front ng plane. So, para mas maintindihan yung formula ng lift and drag force, so as you can see sa figure, yung color red, yun yung airfoil. And yung mga hangin naman na tumatama sa mas Moss curve, yun yung nagge-generate ng low pressure. And yung mga hangin naman na tumatama sa less curve, yun yung nagge-generate ng high pressure. So, paano ba malalaman kung nasaan ang Moss curve and yung less curve? So, yung Moss curve, yun yung may convex side. So, ano bang ibig sabihin ng convex? Yun yung rounded upward. Ibig sabihin, nakapaumbok siya. While yung less curve naman, is slightly concave siya, which means yung curve niya nakapaloob. Blade orientation. So, the question here is, aling side ba ang mas nakaharap at nakatalikod sa hangin? So, first, ano ba muna ang optimum angle of attack? So, yung optimum angle of attack, ito yung kung paano gumagawa ng tilt yung blade na nakabase sa wind direction. So, as you can see sa figure, yung wind direction niya is naka-horizontal. So, ang mas nakaharap sa wind direction is yung may mas less curve para ma-achieve yung optimum angle of attack. So, ano ba ang mangyayari if na-achieve yung optimum angle of attack? So, pag na-achieve yung optimum angle of attack, mas bibilis yung pag-rotate ng blade. Blade rotation. So, yung wind direction is from high to low pressure. So, yung rotation ng blade is depende kung anong side yung mas nakaharap sa hangin. Gaya sa figure na to, makikita na mas nakaharap yung less curve sa hangin. So, ang rotation ng blade is itutulak yung hangin sa less curve na side kasi yun yung mas nakaharap sa hangin to achieve the optimum angle of attack para mas mabilis yung ikot ng blade. Blade design. So, yung design ng blade is hindi lang siya basta naka-curve dapat. Dapat naka-twist and tapered yung blade. So, ano ba ang benefit if naka-twist and tapered ang blade? Nai-increase nito yung speed ng rotation and yung lift force. So, kaya nasabi ko kanina, yung lift force, yung force that makes the blade rotate. At nare-reduce nito yung drag force, which is the force na pumipigil sa pag-rotate ng blade.
Here is now the question. Based on the previous slides, what number of blades is the best design in consideration of all the factors in construction and operation of wind turbine? In designing the blade, the one should be minimized is the drag force, and the one to be maximized is lift force. And for that, here are the rule of thumb. First, the fewer blades, the better, since there will be less drag and an increase in efficiency. Ito yung lagi natin tatandaan. Kapag madami yung blade, it serves as an obstruction. And then, as long as there are many obstruction, mas lumalaki yung drag force. Therefore, the fewer blades, the better. Since there will be less drag, mas konti yung blade, mas mahaba yung drag. Eh yun nga yung gusto natin pababain pag magde-design ng blade, di ba? Okay, next. The number of blade increases the torque and reduces the optimum rotation speed. Parang ganito yan. Di ba yung mga mahilig sa motor? For example, Yung bilang ng ngipin ng sprocket doon sa likod, kapag yun tinaasan mo, ang tendency, babagal. Babagal yung top speed ng motor, pero lalakas siya. Lalakas siya humatak. Ibig sabihin, kung lalagyan mo siya ng sidecar, kung aangkasan mo siya ng mas marami, gaganda yung performance niya. Pero yung top speed niya, kahit ikaw lang yung sumakay, babagal. Just like the increasing the number of blade, babagal yun pag dinagdagan mo yung blade, pero lalakas. Having fewer blades reduces drag, the first rule of thumb. Now, let us now further explain why 3 blades are the best design of all. Here is now the question. If I'm going to ask you, which one would rotate faster under the same circumstances? 1 blade or 3 blade? The one that will rotate faster under the same circumstances is the 1 blade, simply because the fewer blade, the lesser drag. Metras, mas maliit yung drag, mas mabilis yung kanyang magiging rotation. 1 blade. Because of the decreased drag, 1 blade would be the optimum number when it comes to energy yield. However, 1 blade could cause the turbine to become unbalanced. And this is not a practical choice for stability of the turbine. When there are too many unbalanced forces, it would cause a lot of stresses on on the individual parts, which will cause it to worn out easily. So, hindi talaga magandang choice ang 1 blade because of its stability issue. 2 blade. At first glance, 2-bladed turbine seems like the optimal configuration for a wind turbine. Perfectly balanced, and with 1 blade less than a 3-bladed turbine, they will generate less drag. So, why aren't all turbines made with 2 blades? Because it has troubles in yawing. Yawing, ganito yun. Hindi kasi naka-fix itong nacelle ng wind turbine. The whole wind turbine itself should follow the wind direction. Dapat lagi siyang nakaharap sa direksyon ng hangin. E di syempre, pag nagbago yung direksyon ng hangin, susundan niya. Iikot ngayon tong nacelle. Yung pag-ikot ng nacelle na yon para sundan yung hangin, ang tawag doon is yawing. And when the 2-bladed turbine yaw, it becomes wobbly. O edi magkakaroon ulit ng unbalance of force, which put stresses on the individual parts. And for that reason, this 2-bladed design is also an unlikely thing to be selected when it comes to the design of the number of blades. More than 3 blade. Any number of blades greater than 3 would create greater wind resistance. Kasi nga, the more blades you add, the more you are increasing the drag force. So, therefore, it will bring down its efficiency, slowing the generation of electricity and thus becoming less efficient than a 3-blade turbine. That is why, pinaka the best talaga ang 3-bladed turbine.
Next is blade tilting mechanism. According to the wind speed, the relative velocity angle of the wind also changes. A blade tilting mechanism is a sensor-coupled part of a wind turbine, which tilts the blades and guarantees a proper alignment of the blades with the relative velocity, so that its position is always the optimum angle of attack. Meaning, blade tilting mechanism in wind turbines allows the adjustment of blade angles to optimize performance. This helps capture more wind energy, especially during varying wind conditions and improving overall efficiency. Next, the nacelle of a wind turbine houses critical components like generator, gearbox, and control systems. Positioned atop the tower, it enables the conversion of kinetic wind energy into electrical power. And next, the gearbox. the component which converts the slow rotation of the blade into faster speed. This is needly simply because the rotation of the blade generates from the force of the wind is usually not enough for a generator to achieve a grid quality voltage output. Most generators need to be turned at 15 RPM or 450 Hz and 18 RPM for 60 Hz. In no way it is feasible for a turbine blade to move that fast. Meaning, the gearbox in wind turbine serves to increase the rotational speed of the slow spinning rotor to a level suitable for the generator, enhancing energy conversion and efficiency. A common ratio is about 90 to 1 with a rate of 16.7 RPM input from a rotor to 15 RPM output for the generator. Now we have the alternative designs, which is the direct drive or gearless. In a direct drive turbine, there is no gearbox. The main shaft spins the generator directly, causing it to spin at the same speed as the turbine blades. Comparing to gear type, the slow rotation and decreasing in moving parts of PMDD generators reduces fatigue and stresses on the turbine, resulting to reduced noise and vibration, longer lifetime, and lower cost of maintenance. Meaning the direct drive or gearless wind turbines eliminate the need of gearbox, connecting the rotor directly to the generator. This reduces maintenance, improving efficiency, and can enhance reliability in certain conditions. Next is an important fact is that due to wind inconsistency, the gear type turbines often operate on partial loads. The efficiency of the PMDD generators excels even in these conditions because it continues working nearly in nominal values. This design makes suit even on offshore wind applications. Next is brake. The brake system in a wind turbine is the protective device coupled with the sensors which automatically rotation to stop. Brake. Next is brake. The brake system in a wind turbine is protective device coupled with a sensor which automatically rotation of stop the blades whenever it detects activities that could harm the system during operation. Very high wind speed, vital parts not working, or maintenance power lines, and etc. Brake simple definition is when the wind turbine encounters some problem with the other parts, it will automatically shut down the system. The yaw system. Yaw system is a sensor-equipped mechanism consisting primarily of yaw motor, yaw drives, and others. Its function is to automatically rotate the nacelle on the top of the tower so that the set of blades is facing the wind directly at all times. It detects its proper direction through the electronic information being fed by the wind vane located at the back. This ensures that the wind turbine is producing the maximum amount of electric energy. In short, the yaw system allows the rotor to turn and face the wind for optimal energy capture. It ensures the blades are aligned with the wind direction and optimizing power production. And For the tower, wind velocity increases a higher altitude. This means the taller the tower, the greater the greater electricity is it can produce. And for the tower, wind velocity increases a higher altitude. This means the taller the tower, the greater. This means the taller the tower, the greater electricity it can produce. Majority of the wind turbines are supposed by conical tubular steel towers with a height of usually 75 to 110 meters or 250 to 370 feet depending on the blade's diameter. The tallest is still for completion of in the mid of 2022, which is 280 meters, to be installed at the test center in Western Jutland, Denmark. The tower provides heights for the rotor and nacelle, allowing them to capture higher and more consistent wind speeds, enhancing the overall efficiency of electricity generation.
Tower and blade diameter ratio. Dito po sa table, makikita yung mga ratio of nowadays design regarding the height of the tower and the diameter of rotor. Kung mapapansin po noong year 2000 and 2005, mas maliit ang rotor diameter kaysa sa hub height. But nowadays, engineering designs are definitely improving. Dito po mapapansin sa year 2015 is nagsimula na po na lumaki yung average rotor diameter kaysa sa hub height. Next naman po is yung ideal location. The best place for wind farms are in places where wind is strong and reliable, such as coastal areas, at the top of rounded hills, open plains, gap-in mountains, and some are offshore. To have enough wind flow, there should be an average wind speed at around 25 km per hour. Ito naman po yung mga advantages ng wind farm. Una po is wind is free. Wind farms need no fuel. Next po is produces no waste or greenhouse gases. Hindi po nag-e-emit ng carbon dioxide yung wind farm. Next po is the land beneath can usually still be used for farming. Yung lupa pong pinatatayo ng wind farm is pwede pa pong gamitin ng mga farmer. And lastly, a good method of supplying energy to remote areas. Ito naman po yung mga disadvantages. Una po is the wind is unpredictable. It changes speed throughout the day and from season to season. May mga times na sobrang hangin and pwedeng maya-maya na lang is hindi na ganun yung ihip ng hangin. Next is, suitable areas for wind farms are often near the coast, where the land is expensive. Ayun nga po is yung location ng wind farm is mga pili lang. And lastly, can affect television reception on nearby places. Hindi stable yung signal ng TV kapag malapit sa lugar kung saan merong wind farm. Dito po makikita yung mga largest wind farm. Pero ang pinakamalaki po talagang wind farm sa buong mundo and updated is yung Gansu Wind Farm. Yung Gansu Wind Farm po is merong capacity na 7,965 megawatts. And meron po siyang ina-achieve na 20,000 megawatts and ito po ay kasalukuyang work in progress pa. And matatagpuan po ito sa China. Next po is yung Alta Wind Energy Center. Meron po itong capacity na 1,548 megawatts and meron din po itong ina-achieve na 3,000 megawatts na katulad din po ng Gansu na work in progress pa. And matatagpuan po ito sa California, USA. Next is yung Mupandal Wind Farm. Meron itong capacity na 1,500 megawatts and located ito sa India. Next is Hornsea Project 1. Meron itong capacity na 1,218 and located sa United Kingdom. Next is Smart Bygden Wind Farm. Meron itong capacity na 1,120 megawatts and meron din wino-work in progress na 4,000 megawatts. And matatagpuan ito sa Sweden. And yung last po is yung Jaisalmen Wind Park. Merong capacity na 1,064 megawatts and located sa India. Gansu Wind Farm. It is a group of large wind farms under construction in western Gansu province in China. It is the largest wind farm in the world up until now. Over 3,500 wind turbines with an installed capacity of approximately 5,160 megawatts compared po sa Burgos Wind Farm na pinakamalaking wind farm dito sa Pilipinas is mayroong 150 megawatts lang. Burgos Wind Farm. The 150 megawatts Burgos Wind Farm is the largest wind project in Southeast Asia located in Burgos, Ilocos Norte, Philippines. It is consist of 50 wind turbines, each with a capacity of 3 megawatts. Compare po sa Gansu Wind Farm, sobrang liit lang ng Burgos Wind Farm dito sa Pilipinas. Kung tutuusin is wala pa sa kalingkingan ng Gansu yung Burgos. Grid operation. Ito po yung summary kung paano gumagana yung wind turbine. Una po is iihip yung hangin and kapag humangin na, iikot yung blade pati yung gearbox and generator sa loob. And yung generator is connected sa transformer. Yung purpose po ng transformer is to step up the input voltage coming from the generator. Bakit nga ba kailangan mag-step up? Kailangan pong mag-step up para ma-eliminate yung further losses due to very low transmission lines. At doon na nga pupunta sa mga substation na connected sa grid at doon na pupunta sa bahay-bahay due to series of power utilities. And that's all about wind farm. Thank you.